Good morning to one and all. Today we will talk about the concept of minimization of context-free grammar. The various languages can effectively be represented by CFG. CFG is nothing but context-free grammar. In context-free grammar, it consists of non-terminals and terminals. So it consists of some extra symbols in the context-free grammar. So using such extra symbols can unnecessarily increase the length of the grammar. So to reduce the size of the grammar, here we use minimization of context-free grammar. So simplification of grammar means reduction of grammar by removing useless symbols. So in context-free grammar, we are having some extra non-terminals and terminals. So we have to remove those extra symbols. We use this minimization of context-free grammars. What are the properties we have to follow for reducing the grammar? The first one is each variable that is non-terminal and each terminal of G appears in derivation of some word in L. There should not be any production as X implies Y where X and Y are non-terminals. For example, generally the non-terminals can be represented by capital letter and terminals can be represented by small letters. The non-terminals are denoted on left hand side and both terminals or non-terminals are denoted on the right hand side. For example, here if left hand side we have the non-terminal X and the right hand side we have the non-terminal Y. If the production is of the form X implies Y, means the left hand side consists of non-terminal and right hand side also consists of another non-terminal, then that type of production is not to be allowed. Those type of productions must be removed. That is another property. And the third property is if epsilon is not in the language, then they need not be the production X implies Y. Sometimes in the language, if the epsilon is there, then then that epsilon should be removed. If the epsilon is not there, then there need not be the production of X implies Y. So we have to follow these three properties to reduce the grammar. To reduce the grammar, we are following three types. One is removal of useless symbols. Second one is elimination of epsilon productions, and third one is removal of unit productions. Removal of useless symbols means any symbol is useful when it appears on the right hand side in the production rule and generates some string. If no such derivation exists, then it is said to be useless symbol. For example, a symbol P is useful if there exists some derivation in the following form. Here, in left hand side we have in the non-terminal S and in right hand side we have in the terminals alpha, beta and P. In right hand side the middle element P is a terminal. Here the terminals are denoted with lowercase letters and non-terminals are denoted with uppercase letters. In right hand side, the terminal P, from P, it can derive in one string, that is W. So, then the P is called as a useful symbol. Using that P in the right, using the terminal in the right hand side, the P does not derive any string, then that symbol is called useless symbol. Here in this example, the P is deriving the string W, so the P is said to be useful symbol. Consider the example for the following CFG. Here in this example, we are giving variables s, x and y, alphabets 0 and 1, and R we are giving the production s implies xy or s implies 0, x implies 1. So, using this grammar production rules, we have to remove the useless symbols. First, we are writing the given production s implies xy, s implies 0, x implies 1. So in first production rule, we have to observe that S implies xy. Here S is a non-terminal and in right hand side we have non-terminal x and y. From x and y we have derived the symbol. From x we are deriving the terminal x. But y it does not deriving any symbol. So y is a useless symbol. It is easy to recognize that there is no derivation from y. So from y it does not deriving any terminal string. But from x it can derive the terminal string 1. So here we can eliminate the production y because from y it does not deriving any string 1. So after deleting the y, we get the production as s implies 0, x implies 1. Next one, elimination of epsilon productions. In context-free grammar, here we use epsilon productions. So we have to remove those. Epsilon production means A production in P of the form A implies epsilon, then that is called as epsilon production. This epsilon production is also called as a null production. If you apply the production, if you apply the production A implies epsilon, then in the derivation the variable A is replaced by epsilon. A is replaced by epsilon means here the variable A is deleted. For each A in V, there is a derivation of the form A implies epsilon. Then A is also called the nullable variable. So nullable variable means here we are taking V as a set of variables and T is a set of terminals and P is called the production and S is a start symbol. A nullable variable is defined as if A implies epsilon is a production in P, then A is called a nullable variable. First, for example, how we can remove the epsilon production. Here we are taking the context-free grammar production rules. S implies A, S A, S implies B, S B, S implies epsilon. Here left hand side there is having all non-terminals S and right hand side we having the terminals A, B, epsilon and S is a non-terminal. So here in production we having S implies epsilon. So we will place epsilon at S in the sentimental form. So S implies A, S A if in right hand side S implies ASA. Here we have to place epsilon in, so we have to put epsilon in place of S. So if we put epsilon, the S is deleted, then we get S implies AA and S implies BB. So next, so if you remove epsilon, if you apply epsilon to the S, then S is removed, then we get the production S implies AA, S implies BB. Then finally the rules are S implies ASA, S implies BSB, S implies AA and S implies BB. So these are called the epsilon production. Means in production if there is any epsilon, we have to apply that epsilon to that non-terminal and we have to remove that non-terminal, we get the derived string. Next one is the epsilon elimination of unit productions. Say unit production means if the unit productions are undesirable T because one variable is simply replaced by another variable. If one variable is replaced by another variable, then that type of production is called as unit production. That type of unit productions can also be eliminated in the context-free grammar. Consider the following grammar A implies B. Say production B in of the form A implies B is unit production. Unit production means how we can easily identify the unit production means here. If left hand side we having the non-terminal, single non-terminal, right hand side we are having the single non-terminal, then we can say that this production will is a unit production. So we have to remove that type of productions also. So for example, consider the following grammar. A implies B, here B implies AB or B. In the above grammar, the production A implies B is unit production, so we have to remove that grammar and the remaining production is B implies AB, B implies B. These two are the non-unit productions. So how we can easily identify unit production means if there is single non-terminal on the right hand side and single non-terminal on the left hand side. If it is there like that, then we can say that these two are these are unit productions. We have to remove those unit productions. So once again I am repeating, in minimization of context-free grammar, we are using three methods. First one is removal of useless symbols. Second one is removal of epsilon productions and removal of unit productions. In removal of useless symbols here, a symbol is useful when it appears on the right hand side in the production and generates some terminal string. In this example here, we are taking the example S implies xy, S implies 0 and x implies 5. So we are taking the first production rule S implies xy. Here the left hand side we have the non-terminal S and the right hand side we have the non-terminal xy. So from the right hand side non-terminal xy, from the non-terminal x we are getting the terminal 1. So x is not the useless symbol, but from y it does not derive in any terminal string, so y is a non-terminal. So we have to remove that y. So after eliminating the y, we get the production rules are s implies 0 and x implies y. Epsilon production means if you apply the production a implies epsilon, then in the derivation the variable a is replaced by epsilon. For each variable a in V, there is a derivation of the form a implies epsilon, then a is called the nullable variable. A nullable variable is defined as if a implies epsilon is a production in B, then a is a nullable variable. For example, we are taking the epsilon productions. S implies ASA, S implies BSA, S implies epsilon. Here we are applying, here the non-terminal S is having the epsilon. So in right hand side we having small s2 and one non-terminal S. So we have to apply that epsilon to the non-terminal S on the right, S on the right hand side. So after removing S, so S is the non-terminal. So we, after removing this, we get the production S implies A and S implies BB. Finally, we get the S implies ASA, S implies BSB, and S implies A and S implies BB. Next one, unit productions. Unit production means in left hand side we have the non-terminal A and right hand side we have the non-terminal B. Then that type of productions is called unit productions. So we have to remove that type of unit productions. So in this grammar, we are in this example we are taking the grammar production rules as in A implies BB and B implies AB or B. So A implies B means first in first production rule we having the single non-terminal A, in right hand side having the single non-terminal B. So it is in the form of unit portion A implies B. So we have to remove that unit portion, and the remaining grammar is not the unit portion because we have left hand side we have the non-terminal B and right hand side we have the we having the production A B or B. So these two are the non-unit production. These two are not unit. So in contextual grammar, here we having more number of terminals or non-terminals. To remove those extra symbols, we using this contextual grammar. So to reduce this grammar, here we have to follow some methods. One is useless symbols, and second one is elimination of epsilon productions, and third one is removal of unit productions. So these three methods we have to follow. So what are the properties you have to follow for reducing the grammar means each variable is non-terminal and each terminal of G appears in the derivation of some word in L. There should not be any production as x implies y, where x and y are non-terminals. If epsilon is not in the language L, then there need not be the production x implies epsilon. Thank you.